In the last lecture, we learned how to immutably update our state and also manage an array here, which is just like objects special due to that reference types thing in JavaScript. And you learn that you should work with it by using concat. Now I want to handle the case that I delete a result. And for that, we dispatch delete result here. Now in the reducer, the easy part, of course, is to simply add a case for that, add the case delete result, and then we return a JavaScript object where we first of all copy the old state. And now what? What do we do with results? Adding an item immutably was possible with concat. Now you typically remove items from an array by getting the index of the item you want to remove. So let's say we have it here, could be 2. We'll get this dynamically soon. Let's for now just do it like this. And then we could use our array store results and call splice. If we then pass the ID where we want to start as the first argument and the amounts of elements we want to delete with the second argument, we take these elements out of the array. This, however, mutates the original array and therefore is not how we should do it. It's not immutable. So how do we do this in an immutable way then? There are a couple of ways. I'll show you 2. The first is that you create a copy of your array. So new array could be a new array you create, and then use the spread operator to distribute all the elements in state results into that new array. With that, you created a copy of that new array. Important, if the elements in state results were objects, as they actually are, the objects themselves are still pointing to the same objects they did before. So if you change a property in one of the elements themselves, just creating a new array like this isn't enough. If you just plan on removing an object though, that is okay, because you won't touch the object, you just remove it from the array. That's the difference. So we create a copy of the new array here, and then we could simply use that new array here in our splice operation, and then return state where we set results equal to the new array, which is a copy of the old array but updated. And since we copied it, we never touched the old array. So this is one way of doing it. I'm going to comment it out though. The way you see more often is to use the filter method. Now for this, you simply can create a new constant, which is maybe the updated array, whatever you want to name it. You could name it new array, of course, too. And there you take your original array, state results, and call the filter method. A filter returns a new array, doesn't touch the old one, returns a new one. Filter takes a function as an input. The function is executed on each element in the array and determines whether this element fulfills a certain condition to make it into the new array, which is returned by filter, or not. So we get the individual element as an input here, the element, or in our case, the result, we could name it. And then here we have to return true or false. If we just return true, and this is just the shortcut syntax for an arrow function, where if you write it inline, you can omit the return keyword. So if you return true, you return this for every element, and therefore you just created a copy of the old array, so just a longer form of this syntax. Of course, you don't always want to return true, only for the elements which should be included in the new array. So since we want to delete the element here, we return true for every element which doesn't have a certain ID, or which is not at a certain index here. So if we have the index of the element in the array, we would take a second argument we get here in this callback function, the index of the element where we're currently at, so on which this function is executed. And then we could simply say, return true if that index is unequal to the index of the element you want to remove it at. So this is if we're talking about the indexes of the elements. Now in our case here, we have a state of objects or of elements where we have elements of this shape, a value and a unique ID for each element. So we'll actually receive an ID, And we can take this ID. So this is not the index, not the position in the array. This is an ID of the element. And since this function here is executed on each element, we don't need to get the information about which index this element is at. We can just say we return true if the ID of the element in the array we're currently looking at, we're accessing this ID property on each element therefore, if that is unequal to the ID, not equal to the ID we're getting with this action. So for this action, I expect to get a payload of the result element ID, or whatever we want to name it. This is a very long name, you could just use ID, but I want to make it really clear where this is coming from. So this is a payload of this action. Now of course we need to pass this payload, but first of all let's use this updated array to then set it as results here in the state we return. It is an array, a totally new array due to filter, which returns true for all elements where the ID is not equal to the ID we pass with the action. So now let's pass an ID with the action then. Let's go to the counter container. And for delete result, we should now set a property with the same name we're accessing in the reducer. So result LID. That's the property I'm accessing here on my action. And this should now simply be the ID of the element we clicked on. Now to get that ID, we kind of need to get this on this function here. So there I somehow need to get this information. So here I expect to get the ID passed to this anonymous function here. This is any arbitrary argument name you can pick. And I want to send it along with my action. Now of course to receive that here, where we use this property here on delete result, there we now need to pass that ID. So here I'll execute this as an anonymous function. And when this function is executed, then this function will be executed. So now I can add parentheses here because this will now not be executed at the point of time this component renders because it's mapped or wrapped inside this anonymous function. And here I can then pass stored result ID, referring to that new date snapshot. Now with that, if we save all of that and we start adding some results here, and I click on the 30, it is removed. Same of course for the other results if we click on them, but in an immutable way still. And you learn a lot of important things here. You learned how to delete elements immutably with filter. And you learned how to pass actions from within your UI to an action by expecting the argument you get from the UI in map dispatch to props and then passing it along with the action. And of course, by then passing that argument you are expecting here from within your UI by wrapping this prop you execute in an anonymous function, which allows you to pass data along with the function call. This is super important and another core building blocks. Working immutably on deletes and passing action payloads from the UI over map dispatch to props to the store.